We are going to learn how to classify any differential equation as ODE or PDE, linear, nonlinear, and separable or not. If our differential equation is an ODE, we're also required to provide the order. So let's look at this first one, A. dy dx plus 10 square root of x is equal to x squared. What is this? Well, look at the differential equation. That's the first thing you need to do, dy over dx. Now, since it's not being derived by anything else, it's only being derived by one variable, it is an ODE. So as an ODE, is it linear or nonlinear? Well, let's look at our dependent variable. That's what we want. So our dependent variable is y here. It's only occurring once here. It's not contaminated by anything, it's not inside of anything. It is linear. Now, is it separable or not separable? Well, we can move our 10 square root of x to the other side. We can multiply everything by d of x, and we will see that this is separable. For our order, since it is an ODE, what is it? Well, we only look at this one right here. It is an order of 1. So order is just 1. Now, let's look at B. Before we do that though, do you know what an ODE is? It is an ordinary differential equation. And a PDE is a partial differential equation. When we talk about linear, linear is if the dependent variable and all its derivatives occur linearly, so that's by itself in our equation. That's why I kept saying, by itself, not contaminated by anything, just by itself. So now with that known, let's look at B. And for B, we have x cubed minus db over dx is equal to 0. So let's look at our differential equation. It's right here. It's going to be an ODE. Is it linear or nonlinear? Well, our dependent variable b only occurs once by itself. It is linear. Is it separable or not separable? You can move all the x's over. This makes it separable. And the order is just going to be 1 by looking at our differential equation. Now for C, is this an ODE or a PDE? Well, C, we have two dependents right here, or derivatives. And this is our dependent variable. It occurs twice, right here and right there. Now, notice the bottom. This is the important part. It's being derived by two different things, respect to two different things. And since it's being derived by two different things, it is a PDE. So we have a PDE partial differential equation here. Now, is this linear or nonlinear? Well, if we look at our two dependent variables where our actual dependent is used, we can see that, they're by themselves or not inside anything, they're polynomials, so this is going to be linear. Is it separable or not separable now? Well, you can try multiplying these out, whatever have you. You can disregard the constants, set them equal to each other, try cross multiplying, trying to get whatever, but there's too many variables here. And so this is going to be not separable. And since it's a PDE, we do not have to provide the order. So that's going to be it for C. For D, we have the dependent variable y here. It's being derived twice like this. We're assuming it's with respect to like x. So this is an ODE. It's only being derived those times. Now, is it linear or nonlinear? We have three instances of y, all of which are by themselves, they're polynomial, or they're inside of a differential equation. So this is linear. Now, is this separable or not separable? Well, if we have dx underneath our first two kind of parts right here, we won't be able to get rid of it when we multiply it out because it's going to land with this y. So this is not separable. Now, what is the order? Look at the highest of the differential equations. It is 2. For part E, is this an ODE or PDE? We have two instances of it being derived right here, the x. This is an ODE because we can assume that it is being only derived by like dy, for example. Is it linear or nonlinear? Two instances of y, polynomial or not? They're not. Well, they're in differential equations, so this doesn't really matter too much. They're both being derived. They're both polynomial in their respective equation. So this is linear, again, because they're both in differential equation, and there's no other instances, so we don't have to worry about that. Is this separable or not separable? Well, it's E, and it's x. And for x, we have them on the left side, and let's say we're deriving by dy. Well, we can get this 4yt on the other side and we multiply everything by dy, but we still have this t right here. So this is not separable. We can't separate this t out. And the order is going to be 3 because that's the highest. Now let's look at f. Is this an ODE or PDE? Well, we have one instance of our w being derived right here. So it is an ODE. That's all we have to check. Is this linear or non-linear? So we can look at our w's, right? It happens here and here. Since this w, if we disregard the constants, is being multiplied by this w, this regular w is being multiplied by w prime, that's going to make this non-linear. We can't have it kind of, like I said, contaminating earlier. Think of it as contaminating it. So that's what that's doing. Is it separable or not separable? Well, we can take the 3 cosine 3x, move it to the other side, multiply both sides by the respect of d of x, and we'll find that it is separable. And the order is just going to be 1. For g, this is an ODE. It's being derived once right here, our y. So it's an ODE. Is it linear or non-linear? Our dependent variable is y. Checks out right here, checks out right here. It's just y over something. However, this breaks it because y is inside of this e. It's e raised to yx. And so this is going to be non-linear. Is it separable or not separable? Well, because of this e, yx is kind of trapped inside of there. That makes it not separable. And the order for it is just going to be 1. For h, we have one variable, one instance of x being derived. That makes it an ODE, just kind of not automatically, but you can really tell from that. Is this linear or non-linear? Well, let's look at our instances of x. It occurs right here. This is okay. And it occurs right here, just being multiplied in. That's okay. So it is linear. Now, separable or not separable? If we multiply everything by dt, you'll have an issue right here with x dt. So this is not separable. And the order is just going to be 1. You can see that by looking at the only differential equation. Now let's look at I. For I, we have one instance of this right here, y prime. This is an ODE. Is this linear or non-linear? Y is right here. It's the only instance of it. It's pretty simple to see. It is linear. Now, is it separable or not separable? This can be a little bit hard, a little bit tricky, but if you have 1 over dy dx, that's essentially saying you have, and I'll just write it down here, you have dx over dy. And then if you forget about the constant, you can set this equal to a negative 1 over x. You can multiply both sides by x and multiply both sides by dy, and you'll see that you can separate them, so that it is separable, and it does have an order of 1. Lastly, is this an ODE or PDE? Well, we have these two again right here, 2 different variables. Important part is being derived by 2 different things on the bottom. And since they are the same variable being derived by 2 different things, it makes it a PDE. Now, is this linear or non-linear? Well, for this right here, if we look at the variable, it occurs 3 times. This one's okay because it's being multiplied. This is okay, it's being derived. This is okay, it's being derived. So it is linear. Now, separable or not separable? So many variables are in here. You can kind of tell even just from this multiplication right here. It's going to be hard to separate. So it is going to be non-separable. You can divide it by the variable, but then if you try to multiply everything by this, you'll run into some issues. And that's going to be it. That's how you can classify the following differential equations as ODE or PDE, linear, nonlinear, and separable or not.